Let's use models to understand dividing a fraction by a whole number. In this case, we're going to use area models, which I'm sure you are familiar with. Remember, again, area models show a square, and the entire square is 1 unit. Okay, so the whole square is 1 unit. And when we model our fractions, we're going to take that into account. So for our first problem, we have 1/2 divided by 3. Since 1/2 is our dividend, that means it's our starting amount, and that means it is the fraction that we are going to model. So I'm going to divide my square in half, and I'm going to shade in 1/2. And I am going to label 1/2, 1/2. Now, I have to take that 1/2 and divide it into 3 equal pieces. Now, whenever we do fraction models, all the pieces have to be the same. So I cannot just divide the blue half into 3 pieces. I have to divide the entire 1 unit. So I'm going to do that by drawing horizontal lines. And now I have divided that 1/2 into 3 pieces. Now, how do we find our answer? Well, when we use division, if I'm taking a half and dividing it by 3, I am really only interested in one piece, right? If I have 1/2 pound of candy and I divide it among 3 people, I want to know what each person gets. So I'm only interested in one of those sections. And so I am going to shade 1/3 of the whole unit. Now, in order to get our quotient or our answer, we have to look at the part that is double shaded, because that double shaded part represents that half divided into 3. Remember, the second half is just so that our model is accurate. We're not looking at the unshaded half. So I am only interested in this section that is double shaded. And what is my answer going to be? Well, from the model, and if you remember back to multiplication, the double shaded part is the part I'm interested in. And that is, in this case, 1 piece out of, and our denominator is going to be the total number of pieces. Okay, because fraction is always part of the total, and we have 6 pieces. Now, that means that 1/2 divided by 3 is equal to 1/6. Well, when we lose the model and start to use the algorithm, we're going to have to understand equivalent expressions. And if I look at this model of 1/2 divided by 3, I can look at it as multiplication, and I can see it as an equivalent expression. What expression would that be? Well, if this were multiplication, I'm interested in the area of rectangle number 1, and area, remember, equals length times width, and this would be 1/2 times what? Well, my 1 unit is divided into 3 equal pieces, so each of those would be 1/3. And so I am looking for the area 1/2 times 1/3. And so these are my equivalent expressions. Now, because when I talk about division and multiplication, I want every number to look like a fraction, I'm going to replace 3 with 3 over 1, because as we all know, we can write 3 as a fraction. We can write any whole number as a fraction if we put a denominator of 1. Okay, let's pay attention to these equivalent expressions because they will come in handy. Now, let's look at number 2. Number 2 is a little bit more difficult, but the same thought process. Okay, instead of having a unit fraction like a half, I have 3/4 that I'm starting with. So again, 3/4 is my dividend, so I'm going to model 3/4. I'm going to divide my rectangle into 4 equal pieces. I'm going to shade 3. I'm going to make it much wider. Okay, so I'm going to shade 3 pieces, and okay, we need to go back and make sure that our lines are intact. Okay, so each of these is 1/4, 1/4, and 1/4. Okay, it's a little far apart, but you get the idea. Each of these is 1/4. And I want to divide the 3/4 into 5 pieces, so I'm going to divide them this way. I'm going to draw 4 lines to divide them into 5 pieces. Okay, and there we go. Now, remember, what I'm going to do is I am going to, I'm going to shade 1 piece, because remember, if I divide by 5, I'm only interested in what one of those 5 pieces is, right? And so that's going to be this whole thing. Okay, and let me kind of fill this in a little bit. Okay, so what am I interested in? I am interested in 1 piece, right? I'm interested in the part of this model that is double shaded, because remember, we're not counting the 1/4 that's not shaded. So I am interested in this rectangle. Now, what was the original expression? It's 3/4 divided by, and again, I'm going to write it as 5 over 1. I want to find an equivalent multiplication expression from this model. Well, if going down, I have 5 equal pieces because I divided it by 5, each of these is 1/5. Okay, and my multiplication model is showing a rectangle that measures 3/4 by 1/5. And so if I were to find the area, I would have to do 3/4 times 1/5. Again, equivalent expressions, very important for later on when we stop using our models. Now, let's see, what is our answer? Well, let's read it from the model. I have 3 pieces that are double shaded out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so my answer is going to be 3/20. And that's how we use equivalent expressions. Because remember, equivalent expressions have equivalent models. They have the same model because they have the same value. Knowing equivalent multiplication expressions is going to be how we learn to divide fractions without models.